request only a small chunk of that malicious content from the server. So I think we can see where we're going here. We're basically going to be requesting a small chunk. Server in step 4 responds with that small chunk. Next step, the client says, great, can I get another small chunk? And it's going to continually happen until we have everything in place. And as we're getting it back to the client, inside, only in the DOM memory, nothing gets touched on disk here, are we going to have a global variable that's storing all this malicious string, which was otherwise the long, huge, obvious malicious code. Once it gets everything, it's going to execute the resulting code. So, it's a little bit more graphic representation. Step 1, store the malicious content on the server. Same way, say I have this is the set slice phone. Say I have that, I download it from Millworm, some generic exploit. I want to test it out. I store that on the server. I basically, and we can see it's got some obvious things that a signature engine would pick up. I send down the decoder routine. What does the decoder routine look like? Well, it looks like something like this. It's basically, you can do it under 15 lines of code, and if you use some libraries, you can do it under that. And it's just making use, again, of the XML HTTP request, fetching the content. It's kind of on a loop time basis, every 2 seconds, every 1 second, whatever you want to do. You can base it off user action. It's really on how hidden you want to remain. I mean, you can do this slowly. If someone's going to stay on a page for an indefinite amount of time, you don't have to go and fetch content every 4 seconds or every 1 second or every millisecond. You can just wait as user actions are happening. Every click, I'll go get 3 bytes or 4 bytes or whatnot. Step 3, the client uses XML HTTP requests. It goes and fetches that content. It says, hey, index.cgi, I want offset 0, and my request length, the number of bytes I want in that file is 3. You can actually specify that. Web server says, great, goes and fetches it in that file that's unexposed, that's hidden, has our exploit hidden. And if we remember what was in that exploit that we hid on our server, is var space heap spray to address. Probably the most generic type of exploit you can see. It'll send back var. You wanted 3 bytes? I'll send back 3 bytes. Great. Can I get offset 3? I want another 3 bytes. Great. Space HE, which is part of the heap spray to address. And internally, var text is a global memory variable that's hidden inside of the DOM, and it's building up. It's building up as we're asking for offset 0, 3, 6, 9, 12, sending down 3 bytes. Once it has everything, there's 2 methods you can use to execute that code. One is just to call eval. If you call eval, the DOM doesn't change at all. Method 2, which we also saw, was that we can just create an element, script, add it to some node that we'd created, append it. By then, the next step is that it's just going to execute. There's 2 methods. Each of them have their pros and cons. You might want to look a little bit more like a web app. Then you might want to actually use the DOM and change the DOM a little bit more. Also realize that a lot of the JavaScript research tools, they hook document.write and they hook eval. So perhaps by not using eval, that is one way to actually bypass any of the research tools that are being used to try to figure out the obfuscation or try to figure out what's happening in terms of malicious content distribution. So the options for data transfer. Raw, which is what we saw online, I'm just sending down var, I'm just sending down space, heap spray to address, I'm sending it down just in the bytes. I can send it down in XML. XML is cool, it's got all this this language that it specifies what's happening, but it's bulky, right? So we're going to send down more bytes. I could use JSON. So JSON is great. It's JavaScript object notation. It's basically a way that I can send down natively understood JavaScript data. And there's multiple other things that I can do. So if I send it in raw format, we just saw this example, I'm sending down var. If I'm sending it down in XML, data is my tag name, end of file, I have not reached, it's 0. The text equals var. If I'm sending it down in JSON notation, this is the syntax that you'd actually be using. End of file, I can actually include some metadata, which is nice. And in the raw format, I can only guess. I didn't receive anything. Well, it must be done. But if you actually use some type of data format like XML or JSON, you can include some metadata. So end of file is 0 and the text is var. The way you would use JSON here is that the data would equal eval of S, which was that server response, and then I could just reference that text using object notation, data.text, and I can grab that text, which this first one equaled var. So let's talk about, now that we understand that basic attack, let's talk about what's the next step we could even take that. So obviously Flash and PDFs, you can embed JavaScript in there. It's got a certain limitation as to what type of JavaScript you can put in there, but I can put half of my JavaScript decoder in a PDF file, which I could then use between the web page. The more that you can break up the content, the harder it is for anything in the middle trying to bring things together and understand what's going on here. It's going to be. I can also randomize the sequence of offsets. There's nothing to say that I need to ask for offset 0, then offset 3, then offset 6, and so on. Why do that? I'm requesting something. I have intelligence once I'm on the client. I can request object 12, offset 12, and then offset 3, and then offset 0. I can do it in any sequence I'd like to. I can also XOR encrypt the data and include decryption keys. So as I'm sending down each 3 bytes, as we saw in the previous example, perhaps one of the things in my metadata, if I'm using XML or JSON, was the decryption key for the next fragment. So it's that it's really even more difficult to look at or even make sense of what's happening. And this is the more interesting point to make, is that attackers more and more can have use of botnets. I mean, this is like, it's so easy to get use of a botnet for multiple purposes. We saw the cross-domain request object, and what that was I don't just make a request to the object, to the server that I actually came from in terms of my content. I can actually make a request to any single server as long as it allows me to. And if I own a botnet, I'm going to allow that. And so imagine I serve content down to a user, and I make 100 different connections. The content analysis engine sitting in the middle is going to see 100 connections. It's going to have no idea that they are related, and it's all to completely different networks. I can then use, send off saying I want 3 bytes, offset 0 from this host, offset 12 from this host. It can get really confusing for anyone sitting in the gateway as well as the desktop looking at the network. So lots and lots of possibilities of just mixing and mangling and chopping up all my code and asking 1,000 different hosts for all of this. One sec, let me just change my... Alright. So let's see if we can see anything. I think the display is a little different. But what I want to show you is this in action. So one of the demos I used here was the MDAC exploit. I don't know if you want to call this an exploit. It's more like a design bug, but it's 100% reliable. MDAC is still and probably will be included in almost every single WebKit until the end of time. It's effective on IE6, but it's a design bug, which means you don't have to do this heap spraying and have like a 50-50 chance that it might work. You just ask it to ask it to execute something, and it will. So let's see if we can get. Alright, hang on. Alright, so the display, let's see what the display looks like on screen. Alright, well, so what happened is that on your right, I put a web page that I went to visit. And on the left, I'm using a tool called Fiddler.